All right, so what we talked about last time were properties of parallelograms. What we are going to look at today are properties of what we call special parallelograms. Those are our rhombuses, and squares. So what we really have to understand is that all three of them have all of the properties of parallelograms. They have all of the properties of parallelograms. So the opposite sides are parallel and congruent. The opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. All of those properties of parallelograms still apply to these three figures, but what's extra is what we'll talk about in each of these. So let's start with a rectangle. A rectangle is a parallelogram with 4 right angles. Parallelogram with 4 right angles. So again, in addition to everything that we know, opposite sides, parallel, congruent, all that stuff, we have 4 right angles. Okay, and the other thing that's special about a rectangle is that the diagonals are congruent. The diagonals themselves. So if I draw on that diagonal and that diagonal, those are all congruent. The other thing is each of those 4 little segments are also congruent. So for example, if this is 2, then that's 2. If that's 3, then that's 3, and so on. Okay. All right, let's jump over to a rhombus. The special main thing about a rhombus is this is a parallelogram with 4 congruent sides. 4 congruent sides. So all 4 of those sides have the same length. The diagonals in a rhombus are perpendicular. So if you were to draw in those diagonals, they meet at a 90-degree angle. Okay? And then finally, the diagonals bisect the opposite angles. All right, so what that means is if we zoom in here, we already have the diagonals drawn in. Those diagonals cut each angle into 2 congruent parts. So I know that this whole angle and this whole angle are congruent, and each of those angles is cut into 2 congruent parts. The other pair of opposite angles are also bisected, cut into 2 congruent parts. All right, so as you can see how these notes are set up, you have those little arrows that are drawn down from a rectangle and a rhombus down to the square. And that is because a square kind of combines all of the properties of a rectangle and a rhombus. So this is a parallelogram with both 4 congruent sides and 4 right angles. So all 4 sides are congruent, all 4 angles are right angles. Okay, so all of the properties of a rectangle apply, all of the properties of a rhombus also apply. So let's look at a couple of examples. So we're going to start with a rhombus. It says that quadrilateral ABCD is a rhombus. And we are told that the measure of angle BAE is 32. So let's fill that in. Angle BAE is 32. That's this angle. That's 32 degrees. we are looking for, what are we looking for? The measure of angle ECD. ECD, so that's this one. Now, again, what we need to remember about a rhombus is that these diagonals bisect the opposite angles. So this angle is congruent to this angle, is congruent to this angle, is congruent to that angle. So those two angles are congruent. So the measure of angle ECD is also 32 degrees. All right, I don't know if this will let me erase. No, it won't, shoot. But those measures don't necessarily apply to the next problem, so let's get rid of that. All right, next one says that the measure of angle EDC, so that's right here, is 43. Find the measure of angle CBA. CBA is this entire angle. So same type of thing, the diagonals bisect the angles. So this diagonal cuts this whole angle in half. So if this part is 43, that part is 43, that part is 43, that part is 43. So all of those have to be the same. So if I'm looking for the measure of that whole angle, that's just 43 and 43, which is 86 degrees. All right. Let's look at the next one. The measure of angle BEC. So if you look at BEC, that's actually this angle formed by the diagonals. Remember, those are perpendicular. So 3x plus 15, or excuse me, 3x minus 15 has to be equal to 90. Once you solve, 3x equals 105, and then x will equal 35. Okay, the diagonals are perpendicular, so that 3x minus 15 has to be equal to 90. And the very last one, we are told that angle ADE, so let me scratch those out. That's not there anymore. ADE is 5x minus 8. CBE, so that's this one, is 3x plus 24. So again, the diagonals bisect those angles, so those two parts are the same, are congruent. So we'll set those measures equal to each other and solve. I'll subtract, maybe correctly, I'll subtract the 3x. I will add the 8 and divide by 2, so x should equal 16. All right, let's jump down to a square. So number 2, you are told that ABCD is a square. So we know a couple things. Sides are congruent. All angles are right angles. So really that 18 isn't used at all in this problem. We're just looking for the value of x. For that angle, we know it's a right angle. So 5x must equal 90. So x must equal 18. Okay? All right, I'm going to let you guys work on those last 3 examples on your own or with the people at your table. If you have questions, just let me know.